this class I am going to discuss about the combinations. Permutation means arrangement. Combination means selection. In permutation, what actually we are doing? Selecting and then arranging. Whereas in combination, just we are going to select the objects only. Suppose, see, you have here 4 objects are there. A, B, C, D. From these 4 objects, 3 can be selected in how many ways? From these 4, 3 can be selected in how many ways? So from these 4 objects, 3 objects can be selected in 4C3 ways. That is a notation. From 4 objects, 3 objects can be selected in 4C3 ways. But what is that 4C3 value? Yes. See, one selection is ABC. The next selection is ACD. The next selection is ABD. And one more selection is BCD. That's all. From 4 objects, 3 can be selected in these many different ways. But you can observe here, this single selection gives us ABC, ACB, BAC, BCA, CAB, CBA. Array, one selection gives us 3 factorial arrangements. One selection is giving us 3 factorial arrangement. Observe here, I am writing from these 4 objects, 3 objects can be selected in 4C3 ways. I don't know this 4C3 value. Let us say X. This 4C3 value is equal to X. That means X number of possibilities are there. Among those X possibilities, one of the possibilities is this one. One possibility gives us 3 factorial arrangement. One selection gives us 3 factorial arrangements. So X selections will give us X into 3 factorial arrangement. But 4 objects can be arranged in 3 places. In how many ways? That we know earlier discussion. That is 4p3. From this I can write X is equal to 4p3 divided by 3 factorial. So that's why 4C3 value is nothing but 4p3 divided by 3 factorial. So that's what we are going to discuss in this particular class. Permutation means selection and then arranging, whereas combination means just a selection. Each of the different selection that can be made by taking some or all of n distinct objects is called a combination. Number of combinations of n dissimilar things taken R at a time is denoted by NCR. The same we can also write in this way. NCR we can also represent in this way, right? Number of combinations, number of selections of n different objects taken R at a time is denoted by NCR. No doubt 0 less than or equals to R less than or equals to n. Okay, but what is this NCR value? We don't know this NCR value. I am assuming that NCR value is equal to X. Among those X possibility, one possibility gives us R factorial arrangement, because we selected R objects. These R objects can be arranged in R places. In how many ways? R factorial ways. So one selection gives us R factorial different arrangement. But one is giving R factorial arrangement means X will give X into R factorial different arrangement. But this is nothing but NPR. Number of permutations of n different things taken R at a time is NPR. X into R factorial is equals to NPR. Therefore, we are getting X is equals to NPR divided by R factorial. NPR means you know n factorial divided by n minus R factorial by R factorial. So that is the value of NCR. So that is the way how we are getting the formula for NCR. number of combinations of n dissimilar things taken r at a time is denoted by NCR. That NCR is nothing but n factorial divided by n minus r factorial into r factorial. At the same time, we discussed so many ideas related to this. NC0 value is the same as NCn, that is equals to 1. At the same time, NC1 is the same as NC n minus 1, that is equals to n. And also we know that NCR is equals to NC n minus r. And we discussed as a Pascal's identity NCR plus NC r minus 1. NCR plus NCR minus 1 is equal to n plus 1 CR, and also we know that NCR divided by NC r minus 1 is equals to n minus r plus 1 divided by r. At the same time, NCR can be written as n by r into n minus 1 C r minus 1, and at the same time you also know about this particular result. NCR is equals to NCS. Then we can write either r is equal to s, or we can write n is equal to r plus s. NCR is equal to NCS. We can write either r is equal to s or n is equals to r plus s. Now here a simple application based on this particular idea. So tell me first of all, and this particular idea also we discussed NC0, NC1, NC2 and so on NCn. The greatest among all these is NC n by 2 if n is even. Among all these, the greatest value is NC n by 2 when n is even, and NC n minus 1 by 2, NC n plus 1 by 2 when n is odd. These two are greatest among all these NC0, NC1, NC2 and so on NCn. At the same time, we discussed in the binomial theorem chapter C0 plus C1 plus C2 plus and so on plus Cn. Cn means you know Cr is nothing but NCR, which written in the short form as C0 plus C1 plus C2 plus and so on plus Cn is equals to 2 to the power of n. At the same time, C0 plus C2 plus and so on is equals to C1 plus C3 plus C5 plus and so on is nothing but 2 to the power of n minus 1. Regarding all these points we discussed in the earlier classes. Now my question is here, there are n points in a plane of which no 3 points are collinear. There are n points in a plane of which no 3 points lie on a straight line. Like this we have n points are there. With the help of these n points, how many straight lines can be formed? With the help of these n points, let us say these are n points. With the help of n points, out of these n points, no 3 points lie on a straight line. No 3 points are collinear. You can take any 3, these 3, they are not collinear. They are not on the same line. These 2 join one line, these 2 join another line, you will get. So no 3 points are collinear. Then the number of straight lines is equal to get a straight line, we required 2 points. We required 2 points. We required 2 points to get a line. We required 2 points for the line. Any 2 points you can select. Any 2 points you can select, you will get a line. That's why from n points, select any 2 points, we will get a straight line. So number of straight lines is equals to NC2. At the same time, number of triangles is equals to get a triangle, we require 3 points. So from these n points, select any 3 points, you will get a triangle. Select any 3 points, you will get a triangle. Select any 3 points, you will get a triangle. The number of triangles is equal to NC3, denotes for number of triangles, and NC2 denotes for number of straight lines. Now my question is, there are n points in a plane. Out of those n points, p points are collinear. Out of those n points, P points are collinear, then the number of straight lines. Observe here, just for an example, this is one point, this is another point, here one more point, 1, 2, 3. Like that, total we have 6 points are there. With the help of 6 points, we have to get 6 C2 lines. No doubt we have to get 6 C2 lines we have to get. But we are not getting 6 C2 lines. Observe here, join these 2 points, you will get a line. Join these 2 points, you will get a line. Join these 2 points, you will get a line. Now join first point and third point, you will get a line. Join second point and last point, you will get a line. And join first point and last point. Join first point and last point, we will get another line. Now what happens? All these lines, this line, this line, this line, and this line, and this line will be covered under this single line or not? So actually with the help of these 6 points, we have to get 6 C2 lines. But because of these 4 points, we are not getting those many. That's why remove 4 C2. When we are removing 4 C2, what happens? With the help of these 4 points, we are getting 4 C2 lines. We are removing that. When we are removing that, this single line which is appearing for us, the single line which we are observing, that is also missing. That's why add that single line. So that is the number of straight lines. Okay. So now the question is, there are n points in a plane of which except P points, except these P points, no 3 points lie on a straight line. Then the number of straight lines is equal to NC2 minus PC2 plus 1 is the answer for number of straight lines. But what about the number of triangles? Yes, observe here. Here 6 points are there. Definitely we have to get 6 C3 triangles. Because these 4 points lie on a straight line. With the help of these 4 points, we are not getting a triangle. That's why remove those 3 points, you will get 4 C3. No need to add plus 1. Because with the help of these 4 points, we are not getting a triangle. That's why 6 C3 minus 4 C3 is the answer for number of triangles. Out of 6 points, among those 6 points, 4 points are collinear. In a similar way here, total there are n points in a plane. Out of those n points, except these P points, no 3 points lie on a straight line. The number of straight lines is equal to this one, whereas the number of triangles is equal to NC3 minus PC3. That is the answer for number of triangles. Now my question is, the number of diagonals in n sides of polygon. Number of diagonals in n sides of polygon. Observe here, this is a quadrilateral. With the help of this quadrilateral, how many lines you will get? Because total 1, 2, 3, 4 points are there. 4 points are there means how many lines you will get? To get a line, we require 2 points. Select any 2 points. From those 4 points, select 2 points. Total you will get 6 lines. What are those 6 lines? Observe, this is 1 line, 2nd line, 3rd line, 4th line, 5th line, 6th line. But total we are getting 4 C2 lines. Out of these 4 C2 lines, how many sides are there? 1, 2, 3, 4. Remove those 4 sides. The remaining are diagonals or not? That's why if n sides of polygon is there, n sides or n vertices are there, then the number of diagonals is equal to NC2 lines are possible. From those NC2 lines, subtract n sides. NC2 minus n is the answer for number of diagonals of n sides of polygon. You know NC2 is equal to n into n minus 1 divided by 2 minus n. If you take n common, we will get n minus 1 divided by 2 minus 1. That simplification we are getting n into n minus 3 divided by 2. So that is the answer for number of diagonals of n sides of polygon. So number of sides is equal to n, then the number of diagonals of a polygon is given by n into n minus 3 divided by 2. That is nothing but NC2 minus n is the answer for number of diagonals of n sides of polygon. Now my question is here, this is say hexagon. So A, B, C, D, E, F is the hexagon. So with the help of these 6 vertices, how many triangles you will get? Total number of triangles, because from these 6 vertices, select any 2 vertices, select any 3 vertices, you will get a triangle. Total number of triangles is equal to 6, say 3 triangles are possible. Among these 3 triangles, the first question is the number of triangles, and I am asking the next question as number of triangles with exactly 2 sides common with the sides of the polygon. You can observe number of triangles with exactly 2 sides common with the sides of the polygon. This is the triangle. That is the triangle ABC. So you can observe ABC is one triangle. Next BCD is another triangle. Next CDE. Next DEF. Next EF. A. Right? Next we have F, A, B. So these many triangles are possible with exactly 2 sides common. See, for this triangle, one side is the side of the polygon AB, BC is also the side of the polygon. 2 sides common with the sides of the polygon. For this triangle, 2 sides are common with the sides of the polygon. That's why number of triangles exactly 2 sides common with the sides of the polygon is equal to 6. Now my question is number of triangles with exactly 1 side common with the sides of the polygon. Number of triangles with exactly 1 side common with the sides of the polygon. Observe now here. I am taking the side AB, ABD. We are getting one triangle. Next ABE. We are getting another triangle, right? So that's why ABD one triangle, ABE another triangle. If you are taking the side AB, see, observe the triangle ABD. There is only one side common with the sides of the polygon or not? Because this AB is the side of an hexagon also. This AB is also the side of a triangle. Exactly one side common. If I am taking the side AB, we got 2. If you are taking the side AB, we got 2. Similarly, BC case also you will get 2. CD case also you will get 2. DE case also you will get 2. EF case also you will get 2. FA case also you will get 2. That means every side case you will get 2. So that's why number of triangles with exactly one side common is equal to 6 into 2. Because in every side case we are getting 2. So that's why 6 into 2 is equals to 12 triangles are possible with exactly one side common. Now the question is the last question. Number of triangles with no side common. Number of triangles with no side common with the sides of the polygon. Observe here. A, C, E. Now this is ACE triangle. I hope so everyone is observing the triangle ACE. For this triangle, no side is common with the sides of the polygon or not. For this triangle, no side is common with the sides of the polygon. How to find out that type of triangles? Total 6C3 triangles are possible. Out of those 6C3 triangles, 6 triangles have exactly one side in common. Next, 6 into 2 has exactly 2 sides common, these many. Exactly one side common, these many. The remaining is the answer for no side common. Okay, so same we can extend for in case of n sides of a regular polygon also. So observe here, this is one more question. The question is given in this way. Total we have to select 11 players for a cricket team. 11 players we have to select for a cricket team out of 16 players. From total 16 players we have to select 11 players. The first question is saying that 2 players we have to include always. There are 2 special players are there. We have to include them in a team always. These are 2 special players we have to include in the team. Now forget about the 2 players. Remaining how many players are there? 14 players are there. Because 2 special players are there, we are removing those 2 special players. Now remaining 14 players. From those 14 players, more how many we have to select? 9 we have to select. That can be done in 14C 9 ways. At the same time, the second question is asking 2 players we have to exclude always. 2 players are there, we have to exclude them always. Come on, exclude 2 players. From these 16 players, 2 special players are there, we can feel them as waste fellows. So remove those 2 special players. Remaining we have 14 players are there. From those 14, how many we have to select? 11 we have to select. That can be done in 14C11. That is nothing but 14C3, which we can find out. So this is the another question given. A question paper consists of 2 sections. This is the section A, and here we have section B. 2 sections are there. Section A consists of 6 questions. Section B consists of 7 questions. A question paper consists of 2 sections, section A and section B. Section A consists of 6 questions, section B consists of 7 questions. The student has to answer 4 from each section. Total he has to answer 10 questions. Okay, so total from these 13 questions the student has to answer 10 questions, so that minimum 4 he has to attempt from each section. Okay, for that what I am doing, observe here. Suppose he selected 4 from this section, then he has to attempt how many from this section? 6. Right? So that can be done in how many ways? So from 6 questions he has to select 4. From 7 questions he has to select 6. What to do? Multiply. Why we have to multiply? These 4 questions, these 6 questions, he answered total 10 questions, then only his exam is completed. He has to answer total 10 questions. Till the completion of our process, we have to go on multiplication. So that's why from these 6 questions, he has selected any 4. From these 7, he can select any 6. So total 10 questions he answered. Next what I am doing is, from here he is selecting 5. Then from here he has to select 5, because 5 plus 5 total 10 only he has to select. So that can be done in 6C 5 into 7C 5. Next, from here he is selecting 6 questions, and here he is asked to select 4 only. Right? So here selected 6, all the 6 he is attempting, then definitely he has to select 4 from this. That is 6C 6 into 7C 4. Here 10 questions completed. Here also 10 questions completed, different case. Here also 10 questions completed, different case. So therefore, the required number of is equal to 6C4 into 7C6 plus 6C5 into 7C5 plus 6C6 into 7C4. This total sum is the answer for number of different ways he can answer the exam. So this is the another question. The another question is given in this way. Total there are 7 persons. We have to make a committee, but we have 9 boys are there, 4 girls are there. From these 9 boys and 4 girls, we have to make a committee of 7 members. In the first question he is saying that in the committee exactly 3 girls are required in the committee. Exactly 3 girls required in 7 members committee. In this 7 members committee, minimum 3 girls are required. Okay, first of all, from 4 girls, select 3 girls. Alright, total 7 members are required in the committee. We selected 3 girls. More how many members are required for the committee? More 4 members are required. Those 4 members we have to select from boys only. So that's why those boys can be selected from 9. in 9C 4 ways. So this multiplication is the answer, because total whenever 7 members are there in the committee, then only our work is completed. We selected 3 girls, remaining 4 also we have to select from boys. Now our work is completed, our task is completed, right? Next is asking at least 3 girls, minimum 3 girls. What is saying? Take care about these words. At least 3 girls in the committee. At least 3 girls in the committee means what? So I may select 3 girls or I may select 4 girls. Now you are selecting 3 girls means we have to select 4 boys. You are selecting 4 girls means you have to select 3 boys. Now in both the cases 7 members are there in the committee. So that can be done in 4C3 into 9C4 is one possibility. The other possibility is 4C4 into 9C3. So these two sum is the answer for that particular question. 4C3 into 9C4 plus 4C4 into 9C3 is the answer for at least 3 girls in the committee. Next is saying at most 3 girls in the committee. Maximum 3 girls in the committee. Maximum 3 girls. That means maybe 3 girls in the committee, maybe 2 girls, maybe 1 girl, no girl in the committee. So 3 girls in the committee means the remaining 4 we have to select from boys. 2 girls in the committee means the remaining 5 we have to select from boys. 1 girl in the committee means the remaining 6 we have to select from the boys. No girl in the committee means all 7 boys are there in the committee. So that we can write it as 4C3 into 9C4. Next in this case 4C2 into 9C5. Next is 4C1 into 9C6. Next here is 4C0 into 9C7. This total summation is the answer for the particular question. So that is the way of discussion of questions from this. One more idea here I am to discuss. This is the idea. Tell me here, these are the 2 lines. These 2 lines divide the plane into how many parts? These 2 lines divide the plane into 4 parts. First part, second part, 3, 4th part. We will call this as 4 quadrants if they are x-axis and y-axis. Now these are the 3 lines. Those 3 lines, whether you observed or not, the 3 lines are in such a way they are not intersecting at one point. That means those 3 lines are not concurrent. Those 3 lines are not concurrent. Now these 3 lines divide the plane into how many parts? This is 1, second part, third part, 4th part, 5th, 6th, 7th. So total 3 lines. Out of those 3 lines, no 3 lines are intersecting at one point. No 3 lines are intersecting at one point. The number of parts the plane can be divided is equals to, total we got 7 parts. Now my question is, these are the 4 lines. Now these are the 4 lines. Divide the plane into how many parts? Here also you can observe no 3 lines are intersecting at one point. The plane divided into 1, this is the second, 3, 4, 5, 6, 7, 8, 9, 10, 11. The plane divided into 11 parts. Now observe here, when we have 2 lines are there, the number of parts the plane divided is equals to 1 plus 1 plus 2. When there are 3 lines are there, the number of parts the plane can be divided is 1 plus 2 plus 3. Whereas when there are 4 lines are there, the plane can be divided into 1 plus 2 plus 3 plus 4. Right? So that's why if there are same way n lines are there, the plane can be divided into how many parts? 1 plus sigma n. What is the meaning for sigma n? 1 plus 2 plus 3 plus and so on plus n. If there are n lines, out of those n lines, no 3 lines are concurrent. The number of parts the plane can be divided is 1 plus sigma n is the answer. So next class we are going to discuss a few more ideas. Okay, bye bye.